Namaskar, Adab, good morning. Myself Sudhanshu Pandey, and today I'm going to teach you what are Circumcenter, Incenter, Centroid, and Orthocenter in the QMath way. And this video is dedicated to my favorite Manan sir, David sir, Nancy ma'am, and the whole QMath curriculum and tech team. You know, the QMath is one of the best mathematical program in the world, and I'm working with the QMath for the past 2 years. And today I'm going to tell you about what are Circumcenter, Incenter, Centroid, and Orthocenter in the QMath way. Today once again I'm going to tell you that our class is based on practical geometry, in which we are going to learn what are orthocenter, what is an incenter, what is an orthocenter, and what is centroid. To understand this, let's move on to my favorite website, that is Mathigon. Okay, so without wasting much time, let us first understand what is circumcenter. Now, to make a circumcenter, we need just two things. One is this compass. Compasses, we used to say compasses because compass is what we know we use for directions. So this is the compasses, and this is the ruler. These are the two things that we need to make a circumcenter. First of all, you must understand what is a circumcenter. So circumcenter is is a name given to the center of a circle which inscribe a triangle. Let us suppose that we have got three non-collinear points. Okay, these are the three non-collinear points, and if the 3 points are non-collinear, that means they form a triangle. So let me name all these triangles. Let this triangle be ABC. I'm naming it. So this is A, this is B, and this triangle is C. Okay, so let us make three triangles. Let us join all these sides, and I'm taking just a random points. I'm taking random points. So these points are not of any isosceles triangle, any equilateral triangle. These are just random points, and I'm joining them with a straight line to form a triangle. I have joined them to form a triangle. Now you can see the three color sides. One is green, and one is yellow, one is white. Now I need to make a circle which will touch all these 3 points. I need to make a circle, and that particular center of that circle will be known as circumcenter. Okay, so how to create that? So first what we need to do is we need to bisect this line. We need to do the perpendicular bisector of this line. To make this, we have to mark the center as A and taking radius more than half of this line. Taking radius more than half of this line, let us draw an arc above and let us draw an arc below as well. Alright. Then with the center as C, see, I am marking the midpoint here. With the center as C, again I will mark 2 more points. One here, let me make it a bit smaller. Okay, and rotating it, and the next point is here. So what I have done the perpendicular bisector of this line. First of all, I will mark these 2 points, and then I can join these 2 lines. Okay, that can be done with the help of a ruler. This can be kept like this should be kept like this, and then we can draw a line. So this is a perpendicular bisector. Okay, let us suppose that it meets at this point, so I am locking this point as well. Now the same thing has to be done with from the perspective of BC. Let us suppose that I am bisecting BC. So how to do the perpendicular bisector? So with the same center as B and radius more than half, we must just estimate the half of the radius, and let me again draw 2 more arcs. One I am drawing below, and one I am drawing above this line, and then I will change the center as C. Again I will draw 1 more arc and the other arc at these 2 points. Then I will join these 2 points, and we have a point of intersection of the 2 perpendicular bisector. Let me name it as O. Let me name it as O. This point is O. So this point is our circumcenter. So let me show you how. So I am now keeping my center as here, taking any one of the side as a radius, and let me mark with a green color. And if I draw a circle, you will see that the circle is drawn with touching all the 3 points. Okay, now why this theorem works? So this theorem works because, let me show you why this theorem works. So this theorem is based on a logic. This is not centroid. This is circumcenter O. Okay. This point is a circumcenter. So how this logic, what logic is applied here? So the logic applied is here is, so AC is acting as a chord. AC is a chord. We transformed AC into chord, and we transformed BC also into chord. So we transformed any 2 sides of a triangle. In this case, let us say BC and AC into a chord. Now what happened? How I have done that? So there is a property of a circle that in any circle the chord, the line drawn from the center, to the perpendicular, if it is a perpendicular to the chord, bisects the chord. Then there is one more theorem which says that the line joining the midpoint of the chord and the center of the chord is perpendicular to the chord. So that means what I have done is I have drawn the perpendicular bisector of this line. So this is anyway going to pass through a center of the circle which will touch these 2 points. Then the same thing I did with this as well. So that means the center of these 2, the chord, will lie on this perpendicular line. So this is the point of intersection of both the perpendicular bisector, and from here I can say that this is equal to this is equal to this. So likewise I drew this circle which is known as a circumcenter. Circumcenter means it is the center of the circle which inscribe a triangle. Then we must understand what is an incenter. Now incenter is represented by I. Let me see if I am live on YouTube or not. To check. Yes, right now I'm live. Fine. So the second thing that I'm going to teach you is how to draw an incenter. What is an incenter? So incenter is the center of a circle which is inside a triangle, So let me again choose any 2 points, any 3 points. Let me choose any 3 points again. This time I'm going to draw in center for a triangle. So let me again choose the random points. I'm just taking random points. Okay. So let me mark it again as A, B, and C. Okay. So I'm joining these 3 points. So that we can have a different color as well. So this is a random triangle. This is not a isosceles triangle. This is not a we can say equilateral triangle. It is just a triangle. I am taking a random triangle. So for this triangle, now the aim is that we are going to draw an incenter of this circle. Incenter means we need to find a circle which will touch all these three sides. So to find the center of the circle, so that means the first aim is to find the center of the circle. To find the center of the circle, the logic is we have to bisect any two angles. We can bisect any two angles. So first what I'm going to do is, let me mark a point here. So we should always start from a point. So first I will draw an arc to intersect here 2 points. Now I have to, so this is an angle, this is the angle of rotation. So I have to bisect this angle. To bisect this angle, I will put my center of the circle here, taking the radius more than half of it, drawing one arc like this, and then without changing the radius, I am drawing another arc like this. So now with the point of intersection and this point, I am going to draw a straight line. Okay. So this particular line I will term it as, this is the angle bisector of this angle A. Now the same thing I have to do for any other angle. I can do with this or I can do with this. So let me do with this. This might be easy for me. Okay. So now I am going to mark a point. This time I am changing the color so that you should not get confused with the arcs. So this is the arc, and let me mark it here. I'm locking it. So now with the center as this arc, radius more than half of it, I'm drawing one arc. Then with the same radius I'm drawing another arc. Now this is again the angle bisector of angle C. Now the two lines are meeting at this point, and let me mark this point as I. Let me mark this point as I. Now with I as a center and radius, let us say this. Oh, this is more, this is more. So okay, no, okay, fine. So let me take the circle from here, and if I draw a circle like this, not yet touched. Again, let me try. So first of all, okay. Now let me take this radius, and I'm going to draw a circle. You can see that the circle is just touching all the three sides. The circle is just touching all the three sides. If there is any mistake, that might be because of some slight measurements of compass, but more or less we can say that this is the center of the circle, which is known as a incenter. All right. Then now, what is an orthocenter? So let us understand what is an orthocenter, our third figure. Okay, now what is the logic behind this incenter, how this is made? So we will discuss this as well. So this is an incenter eye. And what is the logic behind this? So suppose I draw a perpendicular line on this particular side. Suppose this is a perpendicular line. All right. And I draw one more perpendicular line on this side. I will draw one more perpendicular line on this side. Now let me put this point as D, this point as M, this point as I. Now you see in these two triangles, I can say that this is a radius, these are equivalent. Okay, one more thing, this angle is equal to this angle. This angle was made 90 degree and this is a common side. So by angle side property, we can say that these two triangles are congruent. So these two triangles are congruent means this side is equal to this side, which means this is a radius. This is a radius working for it. So this is a radius working for these two sides. Same goes with here as well. Suppose I see the 90 degree angle here and 90 degree angle here. Between these two triangles, this angle is equal to this angle. This is a 90 degree and this is a common side. So we can say that this particular 90 degree distance, that is the distance of this side from this point, which is a center of the circle, and that distance is known as a radius. So the radius here is also equal. So with that logic, we can say that this is the incenter of a circle, which is equidistant from all the three sides. Now comes the orthocenter. Now what is an orthocenter? So orthocenter is just the perpendicular drawn. Orthocenter is the perpendicular drawn from the vertex to the, so like again let me take any three random points and let me join them. So now this is one more triangle I am making it. This marking I am marking it as ABC. So it's just a random triangle. So now what I am going to do is I am going to draw a perpendicular from this vertex on this line. So to do that, okay, what we can do is, so I am drawing a semicircular arc. So it is skirting at these 2 points. So with this I am going to draw, I am taking more than half of it. So I will cut this and again I am going to cut this. So when I join this is the perpendicular line. Again the same thing I will do from here. First I am going to bisect this line. No, this is more. I have to take a bit lesser radius. Okay. Again this is also more. Some more lesser radius I have to take because this is crossing the line. Okay. Okay. So from here I will take more than half of it. Just I will draw one arc. Then from the other end with the same radius I will draw another arc. So with the point of intersection of these two lines, I am going to draw one more 90-degree line. These both are 90-degree, and you will find when I'm going to draw here, it will meet at this point. Okay, so that point is known as orthocenter. By default, it will meet. So now what I'm going to do is from here, okay, okay, this is more. Okay, this is more. So this is going to be the extended version. So what I need to do is I have to extend this line. See, the perpendicular is not going to be made in the line. So the line has to be extended. So I have extended the line, and this is the point of intersection. Now to draw 90-degree, I have to put this, taking half of it, I will draw one arc, then from here again I will draw another arc. So now this is going to join with this. So I think there is some mistake I have done, probably. Let me draw it again. Let me draw it again, because if it is not drawn, then I cannot quote as well. Alright. So now you see, I am going to join these 3 points again, ensuring none of the angle is an obtuse angle. So first I am going to draw So I'm going to extend this line with a different color. And this is the point of intersection. Now, so I have to take more than half of it. So one arc like this, and without changing the radius. Okay. So actually, let me see if the radius is not changed. So I will take radius more than half of this. I will draw one arc. Then I will draw another arc. Then I am going to join these 2 points. Okay. The same thing I will do from here. So I am going to extend this line as well. Okay. So these are the 2 points. So I am going to make one more perpendicular from here, taking more than half of it, drawing one line without changing the radius, drawing another line, and this is going to be the point of intersection. We can join these 2 points. Now the point of intersection has come here, so this should be the orthocenter. If I draw one more perpendicular line, it should fall on this. So let us see. So this is my first video. Pardon me if in English actually. So please pardon me if I'm not good at English, because my mother tongue is Hindi. So to dedicate 2 of my favorite teachers, I'm doing this in English, or I could have done in Hindi. So again we see that orthocenter is not coming here. So let me see if I need to draw a perpendicular line. Is it going to pass through this point? Okay. Then if I'm drawing a perpendicular line here, it will pass like this. I'm going to stop the video now.